Welcome, everybody. This is our fourth RPF Computing Education Research Seminar of 2025. My name's Jane Waite, and I'll be chairing today's session. And in our seminar series this year, we are focusing on teaching about AI and data science, and we're exploring the research that examines what students should learn about AI, machine learning and data science, as well as the most effective ways to teach these really important topics in schools and further afield. And very, very excited today. We are looking forward to hearing from David Weintrop, Israel-Fishelson and Peter Moon from the University of Maryland, who will be leading our seminar today on how to situate high school data science into the lives of students. And I think it's really exciting to consider how we make it so that it pertains to students' real life experiences. So very huge warm welcome and thanks to our today's seminar speakers. So that's Dr. David Weintrop, Dr. Rotem Israel-Fishelson and Dr. Peter F. Moon from the University of Maryland. David is an associate professor and the Dean's Impact Professor. Oh, well, the amount of research that David has done and that I have personally referenced, and I know people in our team have referenced, is quite crazy, but his research explores how to design, implement and evaluate engaging and equitable computational learning experiences. And he particularly draws from computer science education, design and the learning sciences to inform his work. As I say, he's a prolific writer and it's had some really important contributions to our field. Rotem is a postdoctoral researcher and she focuses on innovative ways to introduce learners to data science through engaging computational experiences. And her work also examines how computational thinking and creativity can be assessed in game-based learning environments. Peter is also a postdoctoral researcher. He's just recently completed his PhD in maths, and we need lots of people from maths to come and help us and to work together with them in order for us to start to teach about data science. So it's great to see that happening here. And Peter has a background in teaching maths, stats and CS, so he really does bring important and valuable classroom experience to his research. And so in today's sessions, the speakers will be introducing API CAN code, an interest-driven data science curriculum designed for high school students. So that's in England, that's equivalent to our secondary schools. And they will be discussing strategies for integrating data science learning into students' lived experiences, increasing authentic engagement and designing meaningful educational experiences. And I am personally very excited to hear about their insights. So over to you.
So like Jane said, my name is David Weintrop. I'm here with my colleagues and collaborators, Rotem and Peter. And we're going to share some work that we've been doing exploring the landscape of K-12 of data science and K-12 education, and in particular a curriculum that we're developing and studying called API Can Code. So the team, right, myself, Rotem, and Peter, and then we also have a graduate student, Yue Shin, who couldn't join us this morning, but this is the core team working on the API Can Code project. So as a high-level introduction and motivation, and I don't know how much of this you're going to need. This is very much preaching to the choir since you all showed up today. But our big picture motivation for this work is recognizing the increasing importance of data in our data-driven world, and acknowledging how important it is for all students to have opportunities to learn foundational data science concepts and practices as part of K-12 education. And importantly, in framing the work this way, we're saying our goal is not to create armies of data scientists, but instead to acknowledge all students need this foundational data literacy to be informed decision makers in the world, to understand the role of data and data science in their lived experiences, give them some agency to operate in this space, to understand what you can and can't do with data and with data science. And we are not unique in holding this opinion. So this was a joint statement that came out from the leading teachers organizations for math, science, statistics, social studies, and computer science. Those are the 5 organizations listed at the bottom. And they put out this joint statement around data science saying data science bridges disciplines and thus should be introduced and taught across the curriculum in K-12 schools to help develop informed users of data. all subjects in school should recognize the contribution of data to their disciplines and take curricular approaches that integrate data with disciplinary lessons where appropriate. So here we're seeing, and it's rare to get such agreement across, science, math, social studies, computer science, statistics, but kind of collectively acknowledging the importance and centrality of data and the need for it to exist, not just in K-12 schools, but across disciplines in the experience of today's students. And another component to the project that we bring is acknowledging that students are living data-rich, data-saturated lives. Everything that they do, the time they spend on phones and social media, like everything that they're doing is creating data. Data is having all sorts of impacts on their lived experiences, both visible and invisible, which creates a real opportunity for us as educators and designers. And so part of the work that part of what we're interested in is exploring ways to harness data that resonates with students' experiences and aspirations. There's all sorts of research showing how this can deepen engagement and increase likelihood of knowledge acquisition. And so data science in particular has this tremendous opportunity to draw on students' interest and lived experiences to situate what we see as really critical 21st century skills, to situate that in their lived experiences and their interests and values and identities. So the big picture goal of our research project, there's kind of two prongs. The first was to understand the current state of data science in K-12 education. A feature and bug of the statement that I just read off about data living in all these different disciplines is that a feature is that it's everywhere, but a bug/challenge is that no one place owns data or data science. And so we're really interested in understanding how and where it does exist in the K-12 curriculum, where it could exist in K-12 curriculum, and thinking about both integrated and standalone visions for data science. So that was kind of the first effort of this work. And then from there, based on what we learned, we're interested in exploring how to teach data science to high school students, and in particular, doing so in ways that draw on their interests and identities. And this gets back to what I was just saying about students living data-rich lives. So, right, like I just said, the first phase was to study current, and this project in particular is looking at data science. We're interested across K-12, but, is focused primarily on high school. We're interested across K-12, but because we also wanted to design and teach a curriculum, we chose high school as our high school. This is students in grades 9 through 12. So this is 15, 16, 17, 18-year-old students before they go off to university. So the first step was to study the current state of data science in high schools. And then from there, we design, teach, and study an interest-driven high school data science curriculum. And so those two prongs are going to kind of structure the talk today. And so with that, I'm going to pass the mic to Rotem, who's going to share some of the findings from kind of that first effort around the landscape of data science.
Thank you, David, and pleasure to be here. So as David mentioned, first of all, before even trying and starting to develop our own data science curriculum, we wanted to examine and understand what already exists. So we compared 4 major data science curriculum, the IDS, the Bootstrap, UCubed, and CodeHS, and we investigate different measures like the technology used, the language, the different topics covered within each one of the curricula, also the data set themselves, and in terms of the size, the recency of the data set, and their proximity. And you have we mentioned the publication related to the one specific I will talk about, but one of the effort was to analyze the data set across these 4 curricula that I mentioned. We examined them based on the size of the data set, the recency, also the topics and the topics they are dealing with, and their alignment with the students' interest. And we saw, as we report in our paper, we saw that many of the data sets are quite small or in between, are spanning between small to medium size. And as for the topics, we saw that they are spanning through different topics, mostly related to sports, some relate to politics and education, which might consider less focused or less aligned with students' interests. We saw some more recent data sets that relate to all topics like social media and TV shows and movies. And with that along, we continued our effort. We also wanted to examine the different tools used because again, in our head was the goal to develop our own data science curriculum, but we wanted to integrate a tool that would be most appropriate for K-12 education. So we reviewed 30 data science tools across different platforms and that exist in different K-12 settings. And we focused on their capabilities, what they offered in terms of data science practices, how they support these practices, like data visualization, statistical calculations. We also wanted to check how these tools are in how students and user can interact with these tools and how they can support learning. Also, we focused on their accessibilities features. We wanted to know if they are provided or not. Unfortunately, most of them are not that good in terms of accessibility, and it's a gap that needs to be addressed. And we have a background in block-based environments, so this was also a focal point in our investigation, and both on the paper mentioned and also in our website, we are providing a full comparison that's available for everyone, in which you can see the different measures we examined. So after, again, trying to understand what is already exist, which tools exist, we transfer and started to design our own data science curriculum. And the first stage on our team was to understand how students perceive data science and what interests them. And to do that, we wanted to create a data science curriculum that students can find engaging and compelling, and also a curriculum that informed by the students. And to do so, we use a methodology called participatory design. For those of you who are not that familiar with participatory design, it's a research methodology that involves the end user in the design process. So researcher and the end user, in our case, the students, because they are the ones who are going to learn with our curriculum, were the focal point in this effort. And we wanted to ensure that the design process reflect their voices and needs and values. And participatory design was already found to be very effective for improving learner materials and also for curriculum development. So we decided to use that. And 2 years ago, we launched participatory design sessions with urban public charter high schools with 28 9 to 12th grade students. It was not virtually, we met with them, we had a few days session with the students. And in this session, the goal in mind was to understand how they perceive data science and what interests the students. And to understand that, we performed different hands-on design activity. Here you can see the name of the activity in our papers. We are elaborating more on each one. But basically, we had different activities in which we try to provide the students opportunity to reflect on their identities, their needs, the perceptions of how data impact their life. In most of the cases, we used low-tech technology. So most of all, we used Post-it notes and big poster in which students could work collaboratively and elaborate on their own perceptions. And I have an example for you. So one of the activities that we had in mind, called the empathy map, It is a user-centered design concept of a persona. So in this activity, students work collaboratively and needed to come with a persona of students in their school. All the prompts that they received were related to data and how data impact their life. So in this case, students needed to elaborate on what the name of the persona, how they describe their persona, what the persona does, what are their concern, and also their interest. And we collected all the data from this activity, the empathy map, but also the other artifact from the participatory design sessions. And we coded everything, and it gave us an opportunity to understand where exactly our data relate to students' life in terms of the apps they use, what are their concerns, and also the area of interest. And we took all of that, and this has helped us to, first of all, think of the topic to be included in our curriculum, but also decide which data set and which topic we want to cover in our data set. And I will pass out the mic to Peter, who will introduce this effort.
Thanks, Rotem. So yeah, as Rotem said, we did this participatory design work, and from there we thought about what kind of curriculum we wanted to build. So if we can move to the next slide, I'm going to take a couple minutes to introduce you to the curriculum we settled on, which follows a 3-unit flow to teach students to explore personally meaningful and real-world data using APIs and 2 other tools that I'll introduce as we go. To give you an example of this flow, we'll look at an activity exploring a Zillow dataset. So in this activity, students explore the costs of houses in their neighborhood. In the case of the school we've been mostly working with, this is in Washington, D.C. And in another part of the lesson, they compare these housing costs to various other parts of the country. It could be, in one case, it's Maryland. In another case, it's a city or town of their choosing. The idea sort of being that, like, what would it cost to live in this other place that maybe I've thought about? The activity starts with accessing the Zillow API. So what students are doing here is first being able to look at and access the Zillow API straight through this Rapid API database. In this screenshot, we're seeing the information that they'll gather from this Zillow API page. This includes snippets of Python code that they're going to use in a moment to request the data. And students can also use this page to test the endpoint, make sure it's live and working. One of the fun pieces of working with APIs is every once in a long while, they do go down. So this, I look at the bright side of this and think we're giving students an authentic experience, which is that sometimes the tech doesn't work. Fortunately, we've built backups to this in case an API ever does go down, but it's real authentic data that is sometimes not available. Moving to our next slide, students take these code snippets and they use them to create a program within a block-based programming environment called EduBlocks. We use EduBlocks for a couple reasons. One of them is that it has direct translation to Python, but students don't generally need extensive programming background to use it. So this is sort of a scaffolded but authentic introduction to programming and data science. We use EduBlocks as a tool for students to process, filter, and iterate through data without, again, without having to sort of type all this text-based code themselves. I do want to just note it's not visible in the screenshot, but on the right side of the screen, whenever students do put a program together in blocks, they see the text equivalent in Python code down the right side of their screen. So they're able to see what program they're creating one-to-one translation. Our last tool is CodeApp, which I'm hoping that some of you are familiar with. But here students are going to import a process CSV from that EduBlocks program and put it straight into CodeApp. For any of you that are unfamiliar, this is a web-based drag and drop interactive data science tool. In CodeApp, students can do things like calculate stats with the data, visualize different distributions and trends, and some higher powered statistical analyses. Despite its very user-friendly interface, CodeApp is actually really capable. It can do a lot of analyses, including ones that we keep discovering as we talk to more and more people who are familiar with it. One of the latest things that we've found out about and included in the curricula are some really neat ways to group data and process out issues like missing data, duplicate responses, and similar problems. So here's a summary of our overall flow through these three tools. Students find data sources through Rapid API. They import them and process them using EdgeBlocks. And finally, they analyze and visualize the data using CodeApp. In the next slides, we'll look at what data science topics are covered using these three tools in the 3 units of the curriculum. So in Unit 1, we're really aiming to introduce students to data. What it is, how it's present in the world around them, how use and misuse of data can affect their daily lives, and different means of collecting and presenting it. This unit has a particular focus on vocab, introducing students to concepts like primary and secondary sources, different types of data, different means of evaluating a data set, including looking at several dimensions of it like size, recency, and trustworthiness. In the second unit, we focus on programming tools to run efficient data science techniques. Students use EdgeBlocks to draw JSON files in from Rapid API datasets, filter data using conditional statements, and print out lists of desired variables in CSV format. We also talk about the advantages of iteration and programmed analysis compared to manual data processing. And we actually have a lesson where we sort of do everything manually and try to make the point to students that this is actually a rather slow and frustrating way of doing data science. In the third unit, students use CodeApp to calculate summary statistics, create graphs, and perform statistical analyses. I'll give some examples, confidence intervals, and linear models to explore different data sets. We also practice interpretation of both pre-made graphs and also the graphs and stats that students are creating along the way. In terms of, we've mentioned this idea of interest-driven in this curriculum. And what we tried to do as much as possible was integrate different topics throughout the curriculum based on topics that students said were interesting in our participatory design sessions. So you can see sort of the topics listed here. These are sort of the most popular from those participatory design sessions. We tried to also cover a pretty good variety just to make sure that every student had something that was in some way interesting to them. Students also have the chance to explore individually meaningful topics in the final project, which we're looking at the layout for here. Really, the goal of this project is to ask students to take on the role of a data scientist. They first identify a data set and question of interest. They collect data from some Rapid API source. We have a very long list of ones that we know work and give sort of interpretable data in organized format. They use EdgeBlocks to programmatically manipulate the JSON file into CSV format with their list of desired variables. And then they create visualizations and other analyses over in CodeApp. Students conclude the curriculum by presenting their results to the class. And to give you a taste of what this kind of looks like and what students have produced, David and Rotem are now going to share their favorite final projects from the class.
All right. Wonderful. Thank you, Peter. Okay, right. So students work through this 3-unit interest-driven data science curriculum. They learn about data. They learn about how to programmatically access and manipulate data, and then they learn how to analyze it. And then, right, it culminates with this open-ended final project where they ask and then try and answer a question using the data science skills that they use. So my favorite project, this is from our first implementation of the curriculum, was a student whose driving research question was, is Janae Aiko a star? I think this is a fabulous research question. Like I love this data science question for a couple of reasons. One is it's personally meaningful to the student, right? This student cares about Janae Aiko, is interested in Janae Aiko, wants to learn more about Janae Aiko. So, right, so we see clearly interest-driven, a lot of student agency. 2, as a curriculum designer, this is not a lesson that I would ever, or an activity I would ever define for students. In part because I didn't know who Janae Aiko was. In fact, when we saw this question, we actually had to go online to figure out how do you pronounce Janae Aiko's name. Janae Aiko is a female R&B musician, right? So in the question itself, it's not just that it's something the student cares about, but something that I, as a teacher and educator, like couldn't possibly design because didn't know who Janae Aiko was. So we see it's like clearly interest-driven, motivated by the student. And then the other part of it that I'm really excited about is the question of whether or not someone is a star. It's like you can't just ask the internet and say this person is a star, right? This is a subjective question. And so it's not just a matter of coming up with an answer, but the student in the process needs to decide how are they going to operationalize star? What does it mean to be a star? Is it sales? Is it tours? Is it streams? Is it... Okay, so this student decided that they wanted to figure out whether or not Janae Aiko was a star. This is their favorite musician. I think they probably kind of knew the answer or they were invested in the question when they started. So anyways, so to go about answering this question, the student found this publicly available data set accessible through an API called Deezer. Deezer is a music streaming platform that has all sorts of data for it. And so she found this Deezer API that she could get information about musicians. She then wrote this block-based program, and again, starting from a template that we provided, and kind of plugged in the information from the Rapid API. They're saying, I want to access this Deezer API. She chose what data she wanted to get back, and you can maybe read it in that first orange print statement. So she was interested in song name, album, artist, duration, and rank. Filtering by whenever the artist is Janae Aiko. So there's the third blue block says query string equals Q : Janae Aiko, and that's again something she could define in the Rapid API interface. And so she said, anytime Janae Aiko is the artist, I want to come back with song name, album, artist, duration, and then pull that into my data set and then create a data set of Janae Aiko songs. And then from there, she built this data set and then pulled it into CodeApp to analyze it. And the way that the student decided to operationalize Janae Aiko was kind of through two different measures. And here we have a visualization of one of them. And so one of them was who has she collaborated with, right? The idea is stars collaborate with other stars. So if Janae Aiko has collaborated with other famous people, then she herself is a famous star. And so in this case, people like Drake and Big Sean and John Legend constitute stars. So this is one way that she decided that, yes, in fact, Janae Aiko was a star. The other graph that she made, which we're not showing here, had to look at the years that she released songs and released albums. So like longevity was another measure for her that would define star. So in the end, the answer to her question was, sure enough, Janae Aiko is a star because she collaborates with other stars and has released music over a whole bunch of years. And to me, this is a really cool, exciting demonstration of what it looks like to have an authentic, interest-driven data science experience, because this is a student using real tools, real live data sets, answering questions that she was really learning about and answering questions that she was interested in and passionate about. So I think it's a really nice demonstration of the thing that we were trying to produce with this curriculum. So that's my favorite final project. Rotem, can you share a bit about your favorite student final project?
Of course. So Janae Aiko was, again, a fabulous example of work that students provided. But this year, I was participating in all the lessons throughout this year implementation. And one of the students chose to work with the Affordable Housing API. And this is a data set that retrieved data from Open Data DC. It's an open platform in which details a lot of data about housing in DC specifically. And the reason that the students chose this data set was, so in her words, she was saying, I moved not so long ago, I moved with my family to DC, but my family is not that satisfied and they considered moving to another place. And when she saw the list of APIs we provided her, she saw that one of the APIs is the Affordable Housing API. And she thought she can take leverage of this project and convince her parents why they need to stay in DC and they can buy a house in DC. So she created this amazing project. She was asking which ward in DC has the most affordable houses. Again, trying to convince her parents where they can buy an affordable house. So she pulled out data from Rapid API. Then, similar to what David presented in the GenAI Code project, she used a template we provided her with EduBox, but she constructed it for her use. So you can see it's a different project and program. So she pulled out the data from Rapid API. Then she decided to pull different metrics from this API about the prices, the different types of housing, from condo to apartment, and also townhouses. She was curious about the number of bathroom and also number of rooms included in each one of the places, and of course the words. She wanted to know if there any difference between the area in DC which the houses exist in terms of prices, and again also what you're gaining through each one of the houses. So after comprising the program in EduBox, she transferred the data into CodeApp. And over there, she created different visualization. We have one example over here in which is comparing different words and also the number of units exist in each word. Again, when the basic data is that all of them are considered affordable houses in DC. She was very excited. She even showed this project to her parents, beside presenting her insights from this project to their classmates. She also presented it to their parents, and I think it's wonderful because again we can see how students bring their own life and their passions, and they can choose data that is personally meaningful to them, and still having the same data science practices and do the same work, but again in a meaningful and very, very interesting way. So that's the reason I personally chose this final project. And it was a hard decision because we have students chose different topics and different data sets, ranging from Pokemon Go to IMDb dataset to again topics that relate to their community, like grocery stores, or as this example as affordable houses. So we saw different variety of topics that were integrated in their final project. And just to wrap up this part of the presentation. So API Can Code is available online and it's completely free. It's supported by the NSF grant, but again, we are providing everything. We have supportive teacher resources, including lesson plans, ready-to-use slides, tutorial video for each one of our lessons. We have discussion prompts and assessment rubric. We also supporting students in their learning. We have example program, EduBox program. We have exit ticket for them to practice what they learned in each one of the lessons. We have FAQs and also glossaries to work with, so they better understand the terms we used along their curriculum. All our activities, and mostly those in the second and third unit, are scaffolded. We are following the use, modified, and create structure methodology, in which students are, first of all, provided with pre-made program. They can run it, see how they works. Then they can modify their codes, and afterwards, they can create their own project, as we saw in the different final projects. And as we mentioned, we are throughout the curriculum, we are trying to use a very meaningful data set. So beside the one students are using in their final project, where they can choose their own data set. Throughout the curriculum, we have different APIs that we integrated, again, ranging from NBA statistics to earthquake and data about Spotify, so different songs and artists. And within each activity, students have their own opportunity to modify the codes according to their preference. And all these data sets were informed by our previous participatory design sessions. So that was also a very important part. And again, everything is available, and you are more than welcome to use our materials and reach out and get our help and support. So what's next? Currently, we just finished our second classroom implementation, which was very exciting. Right now, we have a bunch of data, a lot of data to analyze in order to improve the materials and also have some researchy type insight and that we can share with other educators, curriculum designer, and whoever would like to hear what came out of this implementation. And we always continue to improve our curriculum based on these implementation and insight gained both from the teacher and the students. And we also look for new schools and districts to partner with. So if in this amazing audience around the world, there are educators who would like to work with us and implemented our materials, please reach out. We are here and happy to help. So before I'm passing the mic, I would like to thank you all and well, for this opportunity and introducing the API Concord from on behalf of our team.
A huge thank you to the speakers and for all of you who participated. Can we do another big round of applause? Matti Tedry was here a bit early, and he's actually going to be presenting with Henrika Vartinen from the University of Eastern Finland in our next month's presentation, which is AI as a design domain, empowering students with no-code AI ML app development in the classroom. And that could follow on nicely to this data science course. So if you're interested in finding out more about our series, please do have a look on the website, and thank you again.